Hello everyone. Let's see some more expressions involving exponents and in that process learn more about exponents. So consider 2 raised to the power 2, the whole thing raised to the power 3. How do we go about this? So when you have something like 2 raised to the power 3, we just do 2 times 2 times 2, isn't it? This is what this notation means. So what is this? What is the meaning of whatever is given here? It says 2 squared times 2 squared times 2 squared, right? 2 squared is repeatedly multiplied by itself 3 times. So which if I expand will give me 2 into 2 times 2 into 2 times 2 into 2, right? So if you count the number of 2's, we get 2 raised to the power 6. So we have simplified 2 squared the raised to the power 3 to 2 raised to the power 6. Now let's consider one more example. The second example. Okay, before I go to the second example, I would just like to tell you that 2 squared raised to the power 3 written in this way using brackets will not be equal to 2 to the power 2 to the power 3, right? The brackets makes all the difference. I'll tell you why. What is the meaning of 2 to the power 2 to the power 3? It just means 2 raised to the power 2 into 2 into 2, right? Which is equal to 2 raised to the power 2 2's 4, 4 2's 8, 8. So they are clearly not equal. So always see that whatever we try to mention, whether the brackets are there or not, that has to be noted. And now let's move to the second example. 7 raised to the power 50, the whole thing raised to the power 2. So how do we go about this? What is within the brackets? It's 7 raised to the power 50, which is raised to the power 2, or 7 raised to the power 50 is multiplied by itself one more time. Or if you have to expand this, the 7 times 7 times 7 and so on, this goes on for 50 times, is multiplied, and once again 7 into 7 into 7 so on, multiplied 50 times. So how many times is 7 multiplied here? It is 50 plus 50, 100 times, right? So 7 is repeatedly multiplied by itself 100 times. So 7 raised to the power 50 raised to the power 2 is nothing but 7 raised to the power 100. We have simplified this. There's one more way of arguing the same logic. If you consider this 7 raised to the power 50 into 7 raised to the power 50. This is just like what we saw in our previous video also. Exponents with the same basis, a raised to the power m into a raised to the power n would be the base raised to the power, adding the powers together, a raised to the power m plus n. Right? So this logic, if you're aware of this logic, you may please apply it here. 7 raised to the power 50 plus 50, which is equal to 7 raised to the power 100. But if you're not aware of it, no problem. Still we can explain this. And let's move on to the third example now. What is our third example? It is 125 raised to the power 0. The whole thing is raised to the power 4. So we have something new here. Number is raised to the power 0. A number is multiplied with itself 0 number of times. This is what it means, right? The number 125 is multiplied with itself 0 number of times, which does not mean that this is equal to 0. It means that we get the multiplicative identity, which is 1. So this is equal to 1 raised to the power 4. If it's very confusing, if this part of it, that is, if 125 raised to the power 0 is equal to 1, if this argument is confusing, just consider what is 125 squared by 125 squared. It just gets cancelled, isn't it? The numerator and denominator are same, so you just cancel them or divide by 125 squared, both numerator and denominator, and this is equal to 1. And what is the other way of looking at this? Exponents, same base and you can just subtract the powers. If the bases are the same in division of exponents, it is 2 minus 2 or 125 raised to the power 0, but we already saw that this is equal to 1. So this argument of ours is justified. Right, if you look at it that way, this argument is justified. But we haven't finished the sum yet. What is 1 raised to the power 4? It is 1 multiplied by itself 4 times, which is also equal to 1. So 1 is your answer for this third example. Now let's do one more example, the fourth one, and let's involve a 0 in the fourth example also, just to make our concepts very clear. 125 raised to the power 4, the whole thing raised to the power 0. So it is, first let's deal what is within the brackets. It is 125 raised to the power 4, or 125 is repeatedly multiplied by itself 4 times, and the whole thing is raised to the power 0. That is, it is multiplied with itself 0 number of times, or this is equal to 1. Right. So based on all these examples which we saw here, let us just generalize whatever we have learnt. So on generalizing, if you have a raised to the power m, the whole thing raised to the power n, we can say that this is equal to a raised to the power m times a raised to the power m times so on, and this would continue for n times. Right. This would continue for n times. So if you add all the powers, what would happen? A raised to the power m plus so on. So this would be, how many m's would be there? N m's would be there. Or you can say that this is equal to a raised to the power n into m. Right? So we have a raised to the power m, the whole raised to the power n is equal to a raised to the power n into m, or you can also write it as a raised to the power m into n, because multiplication is commutative here in numbers. So this is our rule. Now let us take this rule, or I'll call it logic. Right? Let's take this logic and look at it, revisit all our examples now. So what was our first example? 2 squared, the whole cube. So if you go by that logic, this is equal to, this is equal to 2 raised to the power 2 into 3, or it is equal to 2 raised to the power 6. These two are the same. The answer which we got initially and the answer which we got using this rule of ours is the same. And let's go to the second example. So it is 7 raised to the power 50 raised to the power 2, right? Which can be said to be 7 raised to the power 50 into 2, which is equal to 7 raised to the power 100. So once again, our answer is the same, applying that logic there. Fine. Third example. Now the third and the fourth example would once again reassure you this raising to the power of 0. So if you have 125 raised to the power 0, the whole thing raised to the power 4. If you apply this rule which we learned, a raised to the power m raised to the power n, you just have, let me change the color, let it be black. It's 125 raised to the power 0 into 4, or 125 raised to the power 0, which is equal to 1, which is the same as the 1 which is here. Right? And what about the fourth one? Fourth one also, this is equal to 125 raised to the power 4 into 0, which is equal to 125 raised to the power 0, which is equal to 1. So our logic, or the rule, the power of power rule, is justified now, right? So let's try to remember this and understand it first, of course. Thank you.